welcome back to John's Workshop, and in this video we're going to do another one in the workshop tips series through circumstance more than anything, and also these are going down quite well. So this is workshop tips number 11, and we're going to be looking at measurement of squareness in the home shop. Now, squareness is a bit of a colloquialism, it's not the proper word, and we'll discuss that in a minute. So, as I said, some simple measurement in a home shop that you can do to check squareness of anything coming off a mill, a shaper, a surface grinder, even a lathe. You know, the squareness applies off most machine tools. The standards, so I learnt this to British Standards 308, which was a long time ago. That's been superseded by British Standard 8888, which is largely the same but revised. I think that was in about 2000 when that happened. And for those of you across the pond, that is an ASME standard, which I believe the latest is Y14.5 with a suffix of M after it. I think that's the latest version. I might be wrong on that. So, as I said, squareness is a bit of a colloquialism. When you look at the actual international standards for geometrical dimensioning and tolerancing that I've just referenced, it talks about perpendicularity, not squareness, and that is the symbol for perpendicularity. So when you see that on a drawing, that means perpendicularity for obvious reasons, but also known as squareness. So we're going to do a bit of a simple how-to, and I'm going to check out my new granite square that I've got and my new measurement gear that I've recently shown in a leather video, and largely just want to run through some simple ways that you can check squareness. And I'll go through some of the ways that you can do that if you don't have a granite square and you don't have, I'm going to try and break it down to the most simplest measurement so that even somebody with the most basic tools in a workshop could get an indication of how square their output is from one of their machine tools. So without any more waffling, I will move over to the surface plate and we will dig in and see what we find. Okay, so we're over at the surface plate. Now, we've stacked this up with some bits and bobs. There are many different ways you can attempt to measure squareness, or as we realised at the board earlier on, perpendicularity, to give it its proper name. And they can range from a standard engineer's square to a homemade engineer's square to V-blocks or 1, 2, 3 blocks, something that you expect to be square but you don't really know whether it is unless you've actually measured it. A standard, so in the case of my granite square that I've just recently purchased, that you'll have seen on my recent leather video if you've watched it, and an array of dial test indicators, that kind of thing. So we're going to go through a few things. Now, you need, what's fundamental if you're going to measure perpendicularity in your workshop at home, and what I'm trying to do here is show you how to do this on the cheap without needing lots and lots of expensive gear, because you can go nuts with this stuff if you really want to. So I've bought my granite square, which not everybody's going to want, not everybody can afford, not everybody has got room for. So you don't necessarily have to have one of these. You have to have something that is square that you can use as your master reference for everything else that you want to try and use to measure squareness. So and the easiest way to demonstrate that is if I take my engineer's square and I want to check that to see whether it's square, I need something as a master reference to check it against. And in this case, now I've got my granite square, I can check my engineer's squares up against my granite square to test whether they're set correctly and whether they're square or not. This one actually is. This one's probably a good 60 years old and it belonged to my dad. I think he made it when he was an apprentice. So that one is square. I've got a couple of other engineer's square that aren't particularly square. I've got my homemade, I made this when I was an apprentice. This is a setting piece for setting things up square in a vise on the mill or shaper or whatever, and again I can check that for square up against my granite square, up against my standard. And I'm going to keep talking about having a standard through the course of this video, because it's something you definitely need if you're going to try to attempt to measure squareness. So what if you didn't have a granite square, didn't want to get a granite square? What else could you use? Well, you could use a 1, 2, 3 block. So you could try and use it straight out of the box and hope that it was ground square, and you know, they may be, you know, even if you've got a really good quality one, they may still not be. So, but what you can do without a master reference, as in the granite square, you can check how square this is, and then you'll know whether you can use that as your reference or not. So the first thing we're going to do is run through that example of how I could check this out, this 1, 2, 3 block, to understand if it is square or not, without needing any other thing to reference it to. So that's what we're going to do first. So I'll clear the table a little bit, give myself a bit more working room, and we'll come back in and show you how to do that. So the first thing, fundamental when you're doing any work on a surface plate, granite surface table, it has to be spotlessly clean. There is no point trying to do any of this work with even the slightest bit of dirt or anything on here is going to affect your readings. Not only that, it's going to damage the surface of your granite. So I've just been over my table with some alcohol on a soft wipe, and the way you find out whether your surface plate or granite table is clean is with this. There's no good wiping it over with a cloth to check that there's nothing on it, or blowing it with an airline. That tells you nothing. This and the nerves in your hand tell you everything. You will feel the tiniest bit of muck under your skin, under your fingers, under your hand, and that tells you whether this is spotlessly clean or not. And I know now that that is, despite the fact I'm disappointed because I've managed to get 2 oil stains on here, which I will work on getting out at a later date. And obviously not only that, anything you're going to put on your granite surface table needs to be as clean. So just checking my 1, 2, 3 block, and you know, the noises and the movements you get also tell you whether this is clean. It would not be moving around on the table like this if there was dirt on it. So there's a lot of indicators that you can have. So the first thing we need to do, if we're going to check whether we can use this as a master for squareness, is we need to understand across its longest length whether it's parallel or not. Because if it's not, that will affect you trying to measure its squareness. So we're just going to use DTI in the height gauge, bring that up onto a 0, and I'm just going to scan along the length of the block and across the width of the block. And this is an import 1, 2, 3 block from China, and I've got to say, best I can measure that with my gear, I can't detect any taper on that at all. So I'm happy that that part is parallel. So now we come on to measuring, understanding whether these 2 end faces are square to the side faces. And if now we know this part's parallel, if the end face is square to one side, it can be nothing other than square to the other side. However, the 2 ends might be different from each other, so it always pays to mark the end that you're measuring against so you don't get mixed up, because they might not both be square to the side faces. So we'll pick an edge, put that onto the table, and this is where we're going to now deploy my new height gauge that I showed in my recent blether video. And the reason I bought this, as I said in the blether video, is because it has this V cutout in the front, as opposed to my other height gauge that you've just seen me using, which doesn't. So what we're going to do is now deploy a steel ball bearing into that V, and it's important that your stylus tip is on the center line as by eyesight of this ball. If it's offset, this won't work. And also you can see that this isn't ideal because my DTI is now cranked over at a bit of an angle, which means I'm going to induce an element of cosine error into my measurements. It's not ideal, but I'm showing you ways to do this on the cheap. So ball cost me nothing. This height gauge cost me £4 or £5 off eBay. So I'm trying to show you how you don't need lots of expensive equipment for this kind of stuff. So what we're going to do now is bring the ball and the DTI up to the edge of the 1, 2, 3 block, and I'm just going to reposition the camera, but I'll show you the movement. Effectively what I'm going to do is roll the DTI around on the ball. You've got to keep the part still, John, it helps. So I'm going to roll the DTI around on the ball to find the high spot. So I'll bring you back, I'll refocus the camera on what we're doing here, or I'll spin everything around so you can see what I'm doing, and I'll show you how to do this. Okay, we've repositioned things a little bit, and I've had to knock one of the lights off to reduce the glare. So this is my new DTI. So each graduation on this clock is 2 microns. So very, very fine. 2 microns is 0.0000078 inches, which is 7/100,000ths of an inch, I think, or just under 1/10 of a thousandth of an inch. So incredibly fine. You don't need to do this. I've bought this because I wanted this, because I want to play around with perpendicularity and squareness, and I wanted an indicator that's going to help show errors much bigger than they really are if you were just using a general DTI. So a normal thou per division or half thou per division DTI will be perfectly adequate for this. You don't need one of these, but it will help with the demonstration. So what we're going to do, I'm going to repeat that movement that you've just seen, and largely you need to roll, you need to try and keep the stylus in the same place, and you roll him round on the ball, and you should see that I've zeroed out. So the highest point I read is on the 0 or just slightly above. And now what I'm going to do is I'm going to spin the block round, which you can't see because I'm zoomed in too far. Just bear with me, zoom out a tad. I'm going to spin the block round through 180, and I'm going to come and measure the exact same measurement on the other side of the block. And it's exactly the same. So because we know that block is parallel, we've got no errors due to taper, and because we're measuring exactly the same value from the base of the block to the top of the block on both sides of the block, that now tells me that this 1, 2, 3 block, these two sides here are perfectly square to this bottom face that we've just been sat on. So that's how you can assess squareness when you don't have a standard to work to. But this, once you've measured that and you understand it's outer square, that could now be your standard. So what do I mean by that? So I'll just reposition the camera, turn the lights back on, and I'll show you what I mean by having a standard. Okay, let's assume, obviously I checked this side and this side facing you to the bottom for square. I've also checked this side and this side for parallelism and squareness to that bottom face in exactly the same way, and equally good results. So I now know that this face and the bottom face that's on the surface plate are truly square to each other within using a 2 micron per division clock I can't detect any error. So what I've now done is, let's assume this block here is something that I've just made, and I want to use that using my reference now, this block, and the faces I want to check for square are the face that's touching the block, my 1, 2, 3 block, and this top face. So I've clamped the two things together. I can now come in with a regular DTI, zero out, and I can now move my DTI across this face and measure if there's any run on it. It's not a perfect way of measuring, but it's an easy way of measuring whether this top face of my block here and the side face are square to each other, and that takes out any influence of this block sitting on the surface plate, because the bottom face might not be parallel, it could be wedge shaped, it doesn't matter. The only two surfaces I'm interested in are the one touching the 1, 2, 3 block and this top face. So in this instance I'm using my 1, 2, 3 block as a reference. I know it's square, I know it's good, so I'm going to use that as a reference to measure this component here. And it's very, very easy to measure that. Once you know you've got a known reference, it can be used for all sorts of other things to check perpendicularity. So here's another example. Now I know my 1, 2, 3 block is my reference. I can now use it to check the squareness of my engineering square by putting a light at the back and checking for intermittent light down the very mating faces of the engineering square and the 1, 2, 3 block. So again, it's about, you know, knowing, having a known reference that you can use as a reference for checking perpendicularity of other components very quickly without having to go to the method that I've just shown using the ball and the height gauge with a DTI on it, which takes a little bit longer and a little bit more effort. So you need to do that for a start, but once you've got your known reference, you don't need to measure that again. You know it's square, so you can just compare other things to it. And let's assume you don't have a 1, 2, 3 block in your toolbox, but you've got one of these, a V block. It's absolutely no different. You would be measuring the squareness in exactly the same way to start with, using the height gauge with the ball to understand whether the bottom face is square to or perpendicular to the side faces or the front faces or whichever faces you choose, and marking those faces. Once you know that they're square, you can then use that as your reference. You can clamp other parts to it to check them. You can use it as a reference, as a master, to check other things for squareness and perpendicularity to. So I've shown the method. There's no, you know, I could go through lots and lots of different examples of this. It's all the same stuff. It's a very, very cheap and easy way to be able to check perpendicularity in a home shop without many tools. And you know, you might not have one of these, so if you've got a machine tool, a milling machine with a flat table on it, use that. You know, it's not gonna get you the same levels of accuracy that you're gonna get from a granite table or a surface plate, but it's gonna get you pretty near. You know, you're gonna be not far away. So yeah, it's just a few simple examples of how to measure perpendicularity, how to check in the first instance whether you've got something you can use as a standard for comparing other things to at a later date, and then making sure that you take care of that. You mark it up, you know where it is, you know which faces you've checked to what, and then you've always got that standard and reference in your toolkit for measuring perpendicularity. And there's a really cheap way. So, you know, I'm going to go through it again. 5 or 6 quid for this, and it was in an awful state, and I've cleaned it up. That was free. Don't know where I got that from. And I paid, you know, I paid £20–30 I think for something that measures to 2 microns per division. So I'm just a thread in a shed here in a garage, and I'm measuring perpendicularity here to within less than 2 microns in a garage with very little investment. So I'm just trying to show that you don't need lots and lots of whiz bang expensive stuff to do this. You just need to understand what the right methods are, deploy some simple things, and you will be able to measure squareness very easily in your home workshop. And just coming back, a couple of side notes here. You know, I was lucky when I did the initial squareness check on this 1, 2, 3 block. I was very lucky, and the parallelism check, I was very lucky that 1, it was parallel, and 2, it was square. Now you might not get that lucky, so one thing I will say is if something's not parallel, don't use it, because you'll be wasting your time. So you're never gonna cope with something that's not parallel, because you're gonna have too many errors to worry about. So you definitely need something that's got parallel surfaces. If you know it's got parallel surfaces, and let's say I measured, you know, one side and I got a reading, and I flipped the block round and I measured the other side and I got a different reading by 1 or 2 thou, say, or whatever, then that tells me that the bottom face of this block isn't square. You know, if it's low on this side and high on this side, then the block is tipped that way. It's as simple as that. The block's tipped towards the high side. So, you know, you could do this with a block of steel in the mill, milling it yourself, or on a shaper, or even you could scrape it, or you could hand work it with a file. You know, as a very basic mode, you could do all of that stuff till you got to the point where, you know, and you'd be hand working or scraping or milling this bottom face to get it square to your 2 parallel faces. Once you've got that to a point where you know these faces are parallel, and you know you're getting the same measurement on one side as you do on the other up against your ball, then at that point you know that bottom face is dead square to these 2 sides. So that's the theory. It's dead simple, and it's a dead simple and cheap way of doing it. And the final tip I would always advise is anytime you're measuring perpendicularity and you're trying to do this kind of check with a DTI or whatever, you know, you should always pick the longest side to do it over. So don't sit the longest side on the table, always sit the shortest side on the table and have the longest side coming up in the air that you're actually measuring against, because, you know, the further up in the air you come, any error that you've got of outer squareness on this bottom face will be amplified. So you'll get something, you know, you'll get a much more accurate check, and you'll get something much squarer if you're working the bottom face, if you're measuring higher and higher up, than if you did it this way round and you were measuring at a much lower level, because that reduces the error that you'll see on the DTI. So with all of that being done and said, I will go back to the board and we'll close this tips video out. So there we go, guys. I hope that wasn't too hard and too difficult. I might have lost some people, and I do apologise if I've done so there. But it's not. It's quite a dry topic. But for people who are interested in it and people who want to do this for themselves, I'm hoping that you found that useful. It's not the easiest of things to explain, so I've tried there to break this down to its most simple and basic terminology, and I've also tried to show you how to do this in a home workshop on a budget with very little materials and input and monetary value required to do this, but how you can, you know, by spending a very little bit on some slightly better quality measurement gear, you can be measuring to aerospace standards and tolerances in a home workshop, in a garage, fed in a shed like me, with very little outlay, just by understanding the principles and applying a little bit of that knowledge and thinking around that perpendicularity measurement. And once you've grasped that theory and you've got a standard that you can refer back to, that will come in very useful for future jobs if you want to check perpendicularity or squareness, you know, whatever you want to call it, off any of your machine tools, or off something that you're making by hand, or off, as I said, checking your engineer squares to make sure that they're in good shape and things like that. It's very, very useful to have something that you've measured yourself and you trust as a standard that you can go and refer back to. And that's exactly how in industry calibration is done of all measurement equipment. Everything is calibrated back to standards, which are then ultimately all calibrated back to a single standard that is kept in a very, very tightly controlled environment, and everything will be measured back to that. So it's that measuring back to standards is really, really important with all of your measurement equipment. And that's why when you buy a micrometer with multiple anvils in it, you'll get the setting pieces or standards, so that you'll know when you've been changing it about, you know that it's calibrated correctly for whatever measurement you're doing. So it's that use of standards, and it's that knowledge of how to use or how to measure perpendicularity, which I'm hoping I've managed to get across in this video. So I hope you've enjoyed that. Hope it wasn't too dry. Thank you to the subscribers and the viewers, and thank you to the new subscribers that have come along, and we'll catch you all very soon on another video when we'll be making something else.